Yes. No, 11 is definitely open.
So it's not prime number.
That's why I said it's
2. 11 is prime.
I understand. Thank you for sharing. All right, so we'll just get some clarification. Like, let's make sure you're okay. So, oh wait, that doesn't work. Yeah, I'll give you a hint.
Thank you.
4, 5, 6, 7, 8, 9, 10. First person goes through. They're all closed.
Yeah, but that's the first person.
I understand.
Oh, really? All of them.
Second person goes through and goes. Uh-oh. Can't have nice things. Third student goes through.
1. 1.
Fourth student goes through.
Oh, it's just the first one.
It's just the first one.
Yes.
No.
Yes.
There's more than one
Every
locker
four.
open.
Well,
Fifth student goes through. 1, 2, 3, 4,
is 1.
5. 1, 2, 3, 4, 5. All right. So that's how you go about it. Figure it out.
You have to go all the way to 1,000
Yeah.
students.
But do it in different periods. Don't do it. Don't do it.
200.
What's the answer?
I don't know. Yeah.
Is it every other time?
No. Well, you're on a thought process. That's good.
So it has something.
So as of right now, this one is definitely closed. Oh, and this one's closed right here, but that might change. So this one is definitely going to be closed. So your hint is the first locker. The first locker is indeed definitely closed. But that's your only hint.
How many lockers are there?
1,000.
And there's 1,000 students.
And each student did the opposite to whatever corresponding number they had. First closed them all. Second did opened every other. Third did opposite to every third.
No help.
Yeah, so as of right now, those two are definitely, I told you to close them, right? Close them. They're closed.
All the other ones are open?
Well, so far I only went through like 5 people.
You have to go.
So there was
through
still student number 6 has to go through, still number 7 has to go through.
And then 7 has to go through, 8 has to go
All right,
through, 9 has
so,
to go through all of
100
them.
million extra credit points if you get that answer to me by Monday.
100 extra credit points?
100 million.
Can you repeat the question?
It's recorded.
Oh, I just know the results.
Actually, we wouldn't have to do anything else in this class.
Now, y'all can't go line up all the freshmen and make 1,000 lockers and make them do it. It's kind of mean and cruel to do that to them. Though it'd be kind of funny. Going, okay, there's like 961 of you. Come here, guys.
Dude, literally shut up.
All right. Let's run through our homework assignment. This is on page 9. Are there any questions on problems 1, 2, 3, 4, or 5? That's the front page.
Oh,
Yeah.
me.
Number 3. Oh, yeah. Number 3. Your favorite jeans are on sale. So you buy a new pair. The total cost includes the 7.5% tax. Okay, so you have a tax of this. And the total price that included the tax is this. So we want to find the price before the tax. So J for jeans times the tax will equal the total. But it's not really that. Okay, so let's figure this out real quick. How do I make 7.5 a true decimal? 0.075. So if I plug that in right there, I'm going to get that. Let's see how that's going to work. So, I would actually have to make, okay, this is going to be tough critical thinking. Let's think about this. If I knew that J was 10, and I multiplied 10 times 0.075, do I get a number larger than 10 or smaller than 10? Smaller. So would you think that if I were to take the price of the jeans right now and multiply it by 1.075, I would get 37.61, or would it be smaller? Smaller. So any ideas what I should do? Well, we will divide eventually. It's set up correctly, but I'm missing something from right there. Anyone have any idea?
0.
No, not a 0.
A 1.
A 1. Good. So if you take your price of your jeans that you're trying to find, and you were to multiply by 1.075, that would then give you the new total. That would be $37.61. Does that make sense? Because paying tax on something means you actually pay more than the sticker price. Agreed?
Yes.
So that's why we need that to be a 1.075 right there. So I need to divide each side by 1.075, and that should give me the price of what the original jeans would be. And I don't have a calculator, so you got to help me. So 37.61 divided by 1.075. $34.98. Do I get a second person to agree? Cool. All right. So that's the little trick on that one. Now,
I got 34.7.
34 point what?
7.
79?
No, we didn't do that.
I don't think we did that.
Yeah, I thought we did.
Okay.
I don't know. You guys have the calculator. I don't have anything.
37.61 divided
How much?
by 1.075. 34.986, so 99.
Nice. Sweet. All right. Let's move to the next one. 1 through 5. Any questions there? 1 through 5.
Yes.
All right. On the second side. 6 through 11. 7. Number 7. The perimeter of a rectangle is 144 inches. The length of the rectangle is twice the width. Find the dimensions. Oh, I have to draw a picture. So I have length, I have width. I know the perimeter because I took geometry once. Is this 2L plus 2W? So what do we know? We know that the length is equal to twice the width. So let's call the width x, and let's call the length 2x. Can I do that? Hey, what did I just do now? I just made it in terms of x. Okay. All right, so let's take a look. So what did we know the perimeter to be?
144.
144. Equals 2 times L. L we just called 2x. Plus 2 times W, which we called x. Agree with the math so far? 2x times 2 is 4x. 4x plus 2x is 6x. You all have a calculator. 144 divided by 6 is?
24.
24 exactly?
Yep. Yes.
So if the... No, that's x. See, that's why it says x equals.
Well,
So that's 24 inches, and this would have to be 48 inches. Yay! What other questions might we have come across? Yeah.
10.
10. Number 10 says you have, no more than, no more than. Who speaks like this? You have no more than 25 feet of fencing. Okay. 25 feet of fencing. To create a rectangular pen for your pet, you plan to use the 10-foot brick wall. So you have like a shed right here, which is 10-foot span. what are the possible widths you can use? Oh, for rectangular pen?
Yeah.
You plan to use 10 foot wide.
So the 10, 10,
Yeah, okay. So if you knew that this side has to be 10, well, we could make it up to 10, right? So that right there could be 10, and then this here, and this here. Being we have a total of, we have at most 25 feet, right? So 7.5 and 7.5?
Yeah.
Because 10 plus 10 is 20. Nope, 7.5 is not right.
2.5.
That's a 2.5. It's 2.5 plus 2 point. So, or wait, no, wait, time out. I'm a dingling. It's 7.5 because here's my fence, 10, and then I have 15 feet left to make this and this. Why is that? Because I have a 10-foot wide shed. So, what does it say? So 7.5 foot width and 10 foot length. So you,
When you say it like that.
well, so you have this being 10. This is 10. So that's 10 foot of fencing because we're using the whole length here of our existing structure. That would leave us 15 feet left, so this has to be the same amount as was this. I think we're right.
Yeah.
Was there anything else you wanted to take a look at?
Number 6.
Yeah, go ahead. 11. These are giving me the tough problems, man. Spike. They got somebody in our word problem named Spike. This has got to be a great word problem. Spike is budgeted between $30 and $45. $45 for his trip to Fun City. Where's Fun City? Is this a real place?
Everywhere.
Okay. He plans to bowl just one game and play laser tag numerous times. It costs $15 to bowl and $4 for the laser tag.
Oh, wait.
All right. How many games? So he plans to bowl just one time. So he has a one-time fee of $15 he's going to drop. So he's budgeted between $30 and $45 on his adventure to Fun City. So I know I have this 15 in the middle plus 4x. X represents laser tag games. All right, so why did I make it a compound inequality? He wanted to spend between 15 and 45, and I guess we could make it equal because he has between $30 and $45 in his pocket. So we can solve it. My arm started. All right. You have there. That's going to be 15 is less than or equal to 4x. So x is less than or equal to 15/4. So he can play between 3, because he's not going to play 15.4 games, right? Or 15/4 of the game. And then this one. $30/4 is 7. So he can play between, he can play 3, 4, 5, 6, or 7 games to stay within his budget. And that's the games of tag.
I think it's only 4 to 7. 3 doesn't work.
Okay. Maybe I didn't read it right.
Because it's 3. Yeah, it's the very back.
Oh, yeah. So this has to be 4. 4. Yeah, because that 3.75, that goofy. You can't play 3.75. All right. All right. Let's make sure names are on those and pass that on forward.
What if I use my little packet?
What?
Should I tear it out?
Yeah, you rip it out of your packet.
I've got. What do you mean?
Yank it out of your packet. I already passed out homework, right?
Yeah. No.
Because it's no longer here, so.
Dude, I'm not even done with Blake. You said that like you're 5 and you're 1. Blake, I think you look. We got one more.
One more? Just trying to remember his name.
Yeah. I forgot it.
It happens.
Oh, okay.
Yeah.
A minute.
So we had a couple of you witness this, but we had a student pass out during the med class today. I think it was the boat prop versus the teenage boy's leg that got the student. So the med class, I had an orthopedic surgeon who came in, and
Who passed out?
I don't know, a girl who weighed about like 105 pounds that I put the brunt of her weight on my left arm.
Was it Tatum?
No. But yeah, all of a sudden I see this sitting in the chair. I see this, and the people next to her are like,
A little bit.
yeah, she was out. She was.
What?
All right,
Is it actually long gone?
but it was a good picture. I like that picture. Boat prop versus a leg.
I checked one.
Boat prop, you know, propeller versus somebody's leg.
Mine is really
He yelled. It was so funny. Like, we have a sleeper.
You like that? That was all right. We have a sleeper.
It was not my brightest day.
Well, you know, you're done water skiing, you're going to get in the boat, and somebody hits the go on the motor. Yeah, it's bad. I will say that the boat wins every time.
Alright, guys. Final drawing. Wait, I'm not finished though. What?
Hey!
We're doing math.
You guys gave me a nice hairline. You guys get extra.
Yeah, this is you. What do you think? What do you think?
You gave me great
You're
hair.
dancing in mine.
Yeah, you gave me great hair. Love you. Love you guys forever.
We did draw you and I had to put a good amount of hair. But
Cooper just drew you bald.
no! That was good.
Cooper's at first to not have any hair.
That is a lie.
Okay.
So is his.
All right, we were. Yeah. Are we ready to play?
Yeah.
Here we go.
Where's what?
Flip around.
His hand is a circle.
What play the game is.
Why is his arm 10 times bigger than his leg?
Okay. A lot of this information we have. I have already taught it, so I'm going to go through, and if you look, if some of the stuff on here is like, I need to see that, I'll work it out. So I'm on the second slide, on the second page. Does anybody need to see order of operations or substitution of a variable and to be solved? Is everybody okay with this? Everyone feels comfortable with the order of operations?
Yes.
So 1, 2, 3, 4, we're good. We don't need to work out these problems. Good?
Yes.
Okay. Next page. So, does anyone need to see equalities? The only thing I would say you need to make sure is that negative distributes here and the negative 2 distributes here. The negative sign is where most people will make errors on these problems. Okay? Does anyone need to see either of those work out? And again, these are reviews, so if you need to, it's totally fine. Don't be shy. Don't feel like you're going to upset the person sitting next to you and be like, man, come on, we get ice cream if we get done. Because we don't really get ice cream when we're done.
We get
We
same thing.
Just a little bit.
It's that big pack.
All right. there. All right. What about these? I need to simplify. I need to get y equals. Does everyone feel comfortable doing that? Anyone going, wait, man, that's new to me. I've never seen that before. Solve it for y. So I mean, this one is just do this. And then move things around so you get y by itself. This one. So get that by itself. We good? May I move on?
Yes.
Kai. Get that. All right, so I will work this one out because literal equations always goof people up. So we have area equals 1/2 base 1 plus base 2 times the height. So this is for the area of a trapezoid. I think maybe someone took geometry at one point. Remember, a trapezoid has two sets of sides that are parallel in length, so they have the same slope, and then they have two sides that aren't necessarily parallel. Okay, you do have a height of a trapezoid. The height is always perpendicular to the two bases. So let's see, they want us to solve this for B1. My first move here would be doing this. What did I just do to get there?
Multiplied by 2.
Yeah, I multiplied both sides, so right now I have one term being A and another term being this whole side. So I multiply both sides times 2, and that would have eliminated the half. Then I'm going to divide both sides by h. And I can get rid of my parentheses now because there's nothing to be distributed over the parentheses. Does that make sense? And then I want B1 all by itself. So B1 is going to equal 2A over H minus B2. And we're done as far as that one. Then it says the above formula is the area of a trapezoid. Use your answer in problem 7. I don't think we need this. Okay, because we have everything here. All right, so we're going to use this equation here and to solve the missing base. So I do know that the area is 126. Okay, so I know that B1 equals 2 times 126 over H. So our height is 6 minus B2, which is 24. Is that okay?
Yeah.
Doing a little math, that goes in there, what, 21 times? 2 times 21 is 42. 42 subtracting 24 is 18, I believe?
Yep.
So my base that was missing is 18 inches on this trapezoid. What do you think? Did I do it okay? H. This 2 right here?
Yeah, why isn't there 2?
Okay, so I have one side here. Here's my first side. So let's circle that in yellow. Here's my first side. And then here's my other side. So I only have really 2 terms.
Yeah.
So if I multiply this whole side that's all being put together by 2, the half and the 2 cancel out, so it's gone. So that doesn't go there. The 2 goes there, though.
But wouldn't the 1/2 only be affecting the B1 plus B2?
But everything's being multiplied together, even the grouped part. So treat this quantity, so this would be the same thing as if I had this, x times h, where x just happens to be a quantity. So it's the property of multiplication that we're doing. We okay? Can I move on? All right. No? Does everyone feel comfortable with this? The big error that would take place here is you got to make sure you distribute the negative to both numbers. So what was inside the parentheses? Both signs change. Does anyone need me to go any further on this question? No. Going once, going twice. Sold. Okay. Compound inequality. I could do this. Multiply both sides by 3 over 2. That would become 18 over 2, which is 9. And then this side subtract 6. Divide by 3, so this sign has to go opposite. So if I plot this, it's an OR statement. So we're only finding where it could be true on both, but it doesn't have to be. So if I had 9 here, solid dot, and this is going this way, say 0 here and -2 here. This is an open dot going this way. Think about this. This is going to continue forever this way. And then this is going to continue forever this way. Okay? Being it's an OR statement, we have to find, if we find a value that makes both of our problems up there false, it doesn't work. Okay? But what about that -2? What does that -2 not make work? So I have this value right here. Does that work on this problem? Does it make it true? If I plug -2 in, let's walk through it. 2/3 of -2 is -4/3. -4/3 added to 2 is positive 2/3. Is 2/3 less than 8?
Yes.
Yes.
So does that -2 work? If I take the -2 and I plug it in here, I wind up getting that 12 is greater than 12. So that's false. So the -2 gives us a true statement here and a false statement here. Being that it's true and it's an OR, our answer has to go from negative to positive infinity. It's all your real numbers. Does that make sense?
Yes.
So you're just trying to figure out where would we have untrue answers. And what always drove me nuts when I was doing math, it's like, how are you picking a number to work? And what I could do is if I went way this way, and say I picked like -100, if I plug -100 in here, it would work for this problem. If I picked +100 here, it would work for this problem. And everything in between is going to work. So just be cautious when you're working those types of problems. It can get goofy, but I think you can handle it. So just remember the OR. If it's an OR, you're looking for if you have all true, true, or true, false, or false, true amongst your terms. False, false does not work. It's not part of your solution set. All right? May I move on? This is an AND. So AND has to work when you have only a true, true. If you have a false region, you can't use it. So I think this is the same exact problem that we had just done, right? Is it the same? So -2 to 9. So this is what the graph would look like. It doesn't continue forever. Okay, remember our last graph continued forever this way and it continued forever this way. And your graph does with each one independent, but you're looking for the region that would create true, true, and that has to be the overlapped region. So remember that we'll go from -2 to 9 square bracket for our interval notation. That's the difference. It's the exact same graph. It's just this one back here works going forever, but now we're worried about this section right here on our next picture. So it has to be in between. The in between here would give us true and true on both. So the true and true, meaning if you pick a point in between, it's true in the first statement and the second one. Okay, for the and to work. So that's the exact same problem, it's just they changed the or to and. Okay? Yeah?
I think it goes -2 is greater than that because the sign's flipped.
Right, flip it.
No, like that one's right. I think. But the next one, the and statement.
Did the equation change? 12?
Yeah.
This is the same equation as the last one, isn't it?
No, the sign is flipped. So you have like the -3 and you have to flip the sign. So then
You have to divide it. And you flip the sign because it's a negative.
I flipped it over here, right? I
No,
solved it.
but the sign
Yeah,
on
but
the
the sign
next
is
one's
turning.
flipped, so like it's facing towards the -3x, not the 12 on the next equation.
This one is 12 is greater than.
See?
Oh, that right there. Oh man, what a sneaky trick they pulled on me. Oh man, I tell you. All right, so that means we forget this answer. So that's gonna work. Oh, it did work because hang on. Where is it? So you're saying it's going to go that way now. So this actually went a round circle going this way. And then this one is going to go still this way, yes?
Yes.
Okay. You know what? Change this on your paper. That way it's the same. I think we were trying to get the same problem. So just change that. So that was an error on our part. What time are we out of here? 11?
Yes.
Sweet. Okay. This particular problem, make sure you break this up into the two problems that it is. Does anyone need this worked out? I was just trying to point out that this went to both equations that do it the same way. This, as it's sitting, if you have inequalities where you have two inequality signs with something in the middle, this turns into an and problem. It's an and problem. You're looking for the true and the true. Okay? So an or problem always has the word or in it. An and problem we can put together like that, and then you're looking for the true. All right. Andrew has $50 for his day at Boondocks. It costs $12 for lunch, and he decides to play one round of golf, and he would like to play some laser tag. That costs $6 per game. So we have to do less than or equal to, I guess, 50. So that's 20 plus 6x, less than or equal to 50. So 6x is less than or equal to 30. So it looks like our friend Andrew can play up to 5 laser tag games and not run out of money. He might not have played 4, he might play 3, 2, 1, or none. But if that's how his budget's going to work, that's how it's going to work. We should all go to Boondocks, right? Go have fun.
That's right.
We'll play laser tag. Great thing in laser tag, every now and then you got that one step that they forget to tell you about. The guy's running through it and they just, it's like, wow, laser blew your tooth out.
You always have the guy who tries to cheat.
There's always someone who gets hurt. That's always the best friend to hang out with, the friend who always gets hurt. All right. Hey, you and your 2 friends. So how many people are you talking about? 3 of us. Okay. Split an Uber ride. The cost of the ride is $11. If it is $2 per mile at a flat rate of $4, how far can you go? All right. So you spent $11 on this ride. You paid $2 per mile, and there was a flat rate of $4. So you pay the $4 regardless if you rode or not. Subtract that. So I'm going to get 7 is equal to 2m. So it looks like you did 3.5 miles on your Uber trip.
If you run out of money, do they just kick you out?
I have no idea. I don't know what the rules are. Do they? Time to get out of here.
So you just like driving out desert, you're out of money, let's kick you out.
Hey, you wait till you take a road trip with your buddies. You're gonna have the one buddy who's gonna sit there and make the noises in the car the whole time. Like you're gonna be driving, and all of a sudden you start hearing, like, man, we got a flat. And then you're gonna realize at the next rest stop you're gonna leave that person.
Yeah, right?
So you guys remember summer 5 days ago? You remember the road trip you went on with your parents? Did any of you do that in the car?
No, I think it wouldn't be.
Dad, stop. All right, ready? You have the calculators. We can get this done. David decides to save 5% of his annual savings for his kids. So 5% is 0.05 times his annual savings allowed him to save. Some of you are being rude. So David decided to take 5% of his annual savings and save it for his kids' college. He saved $3,120 last year. So you have the calculator. Help me out. What's 31020 divided by 0.05?
62400.
62400. So David made $62,400. Is that the last slide? It's like, we'll always say it's the last slide. So your assignment for this weekend, 1E. That's it, right?
I guess you can say it.
1E.
I'm the undisputed.
And then, so you know, Tuesday next week, we have a quiz, okay? So 1E is your homework tonight. Quiz on Tuesday. Will someone bring me my phone, please?